Hello everyone, this is 7.4 part 2, so I just wanted to let you know if you're watching this one first for some reason you need to go back and watch part 1 because this won't make sense. But at any rate, I went over the 6 trig functions at the value of 0, pi over 2, 3 pi over 2. And this chart, we can kind of blow it up here, tells you everything that we just found. So I'm not going to go over that because we have already done that. So anyways, we're going to go ahead and look at objective number 2 now. It says use the coterminal angles to find the exact value of the trig function. This is important because in trig we kind of luck out, because if we know how to find all the values from 0 to 360, we're in good shape. Because if you look at the diagram here, at this point we have the same value. We have this positive angle and we have this negative angle. But the beautiful thing is at that point, the values of the 6 trig functions are the same. So what does that mean? That means we can do a lot of things with these. So if we've rotated clear around, like let me erase what I just drew there. Like let's say we started at the x-axis and went all the way around, we can subtract 360 from whatever that value is where we have our angle, and we'll find out the same value is what it is without rotation around. So it's kind of a really neat thing. Okay, so let's go ahead on to the next screen. And let me just erase that really quick. All right, so it says find the exact value of the of each of the following. It's kind of fuzzy on mine, so sorry about that. All right, so for hold on a second, let me go back there. For part A, it says to find sine at 390 degrees. The first thing you have to do with these is find what value it's supposed to be. I don't know what 390 degrees is, but if I subtract 360 from it, I find out that I'm actually looking for something for 30 degrees. So I know what sine of 30 degrees is, and if you don't know, you need to definitely make some note cards. I'm just doing this to kind of help you out, but you need to know this. So if I look at 30 degrees, it's opposite over hypotenuse, which is 1/2. Okay, so sine at 30 degrees is 1/2, just as sine at 390 degrees is equal to 1/2. Okay, for part B, we now have 420. So the first thing we do is subtract 360 from that, because once again, I don't know what 420 is. So if I do that, I get 60 degrees. Now I have an angle I know, and now I'm going to find out what cosine of 60 degrees is. So if you use the triangle I just drew over there, if we look at 60 degrees, cosine is adjacent over hypotenuse, so that is 1/2 as well. So cosine of 60 degrees is equal to cosine of 420 degrees, which is equal to 1/2. For part C, tangent is of 9 pi over 4, the radians. So here's the deal. 2 pi is equal to something with a denominator. In this case, the denominator is 4. So I'm going to double that and get 8. I'm going to get 8 pi over 4. Now 8 pi over 4 is equal to 2 pi. Okay, it's just finding a common denominator. Okay, so 9 pi over 4 minus 8 pi over 4, because that's 2 pi, I get pi over 4. All right, I know what that is. That's 90 degrees. Or sorry, it's not. It's 45 degrees. So basically, I'm looking for tangent of pi over 4, which is 45 degrees. The 45-degree triangles are 1, 1, radical 2. Tangent is opposite over adjacent, so the value is 1. So tangent of pi over 4 is equivalent to tangent of 9 pi over 4, which is equivalent to 1. Okay, part D. Part D wants us to find negative 7 pi over 4. Okay, so once again, I know that 2 pi is equivalent to 8 pi over 4. So if I take 8 pi over 4 and subtract 7 pi over 4 from that, I get pi over 4. So what is secant of pi over 4? Remember, secant is the reciprocal function of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent, so it's radical 2 over 1, or just radical 2. Okay, and for part E, and I'm running out of room, so I'm going to erase the first part, so hopefully you already have this written down. For part E, whoops. Okay, so for part E, I'm going to write it over here. It's cosecant of negative 270. For this one, because I know I'm on an axis, I'm just going to redraw this. So this is 0, this is negative 90, this is negative 180, and this is negative 270. Now, negative 270 is right where 90 degrees is. Okay, so what is cosecant of negative 270 degrees? It's cosecant of negative 90 degrees. Okay, cosecant is the reciprocal of sine. At that point, at 90 degrees, we have 0 and 1. Remember, sine is the y value. So taking the reciprocal of that, I get 1. Okay, so down here, it's just saying, hey, if you get a value that is larger than 360 degrees, what you can do is subtract 360 from it. Also, remember that 2 pi, if you have to make a denominator, like let's say the denominator is 6, then you double it and you get 12 pi over 6 is equivalent to 2 pi. If the denominator is a 3, I double it and I get 6 pi over 3. If the denominator is 4, I double it and I get 8 pi over 4. So those kind of things will help you understand how to do these ones. Okay, objective number 3, determine the sine of a trig function of any angle. Alright, so here's the deal. In quadrant 1, x is positive and y is positive. Okay, in quadrant 2, x is negative and y is positive. In quadrant 3, x is negative and y is negative. In quadrant 4, x is positive and y is negative. Okay, so remember, cosine, sine. Cosine goes with x and sine goes with y. Alright, so in quadrant 1, everybody's positive. In quadrant 2, sine is positive and its reciprocal function. In quadrant 3, tangent is positive, because remember, a negative divided by a negative gives me a positive. In quadrant 4, cosine is positive, as so is secant. So there's a mnemonic device you can use. You can either use the plus, negative, negative, plus, negative, or you can use this, all students take calc. So all students take calc, that means all functions are positive in quadrant 1. Sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. And cosine and secant are positive in quadrant 4. In quadrant 2, 3, and 4, the other functions are all negative. Okay? So for instance, cosine. Cosine in quadrant 2 is negative because only sine and cosecant are the positive ones. So this is very handy. I'd highly suggest memorizing this or this one, or both. Okay, so here's an example where we would have to use that. If sine of theta is greater than 0 and cosine theta is less than 0, name the quadrant in which the angle theta lies. So if we use all students take calc, sine is positive. That's what that means, greater than 0. There's only 2 quadrants in which sine are positive, so we have 2 that we've narrowed it down. Now cosine is less than 0, so cosine is negative. It can't be in quadrant 1 because everybody's in positive in quadrant 1. So it has to be quadrant 2. So the answer is quadrant 2. Okay, objective 4, find the reference angle. I do want to go over this definition really well. A reference angle is an angle that lies in a quadrant. The acute angle formed by the terminal side theta and the x-axis is called the reference angle. So guys, acute angle means less than 90 degrees and we have to use the x-axis. So when we do these, we're going to be using 2 values, 180 or 360. Those are going to be the important values. Okay, so let's see what this all means. All right, reference angles. There are some pictures up at the top. Let's look at them. This angle is in quadrant 2, so to find my reference angle, I have to take 180 minus the angle. The next picture, we're in quadrant 3, so I'm going to take the angle minus 180. In quadrant 4, I have to take 360 minus the angle. In quadrant 1, it is okay, so you leave it alone. So let's look at the first one. Find the reference angle of 220. Okay, let's find out where that's at. 0, 90, 180, 270. Okay, 220 is right here. Okay, so remember I'm creating an angle. If I create a triangle, the base is formed with the x-axis. All right, so 220 is here. So how do I find what the reference angle is? I take 220 minus 180. Why? Because that's the x-axis and because I'm in quadrant 3. So when I do that, I get 40 degrees. That's a reference angle. Reference angles are acute angles. Always use the x-axis. All right, find the reference angle of the angle. Okay, I don't know about you, but I don't really want to work with the radians, so I'm going to go ahead and get rid of them. So pi and pi cancel out. 5 goes into 18 3 times, and 5 goes into 36 times. Now we have 12 times 36. Okay, 12 times 36. I'm going to work the math out right now. I got 432 degrees. So I'm dealing with 432 degrees. Where is it? Well, I know it's well past 360. So let's go ahead and subtract off 360 from that. And when I do that, I get 72 degrees. 72 degrees is in quadrant 1. Okay, I'm good because that is an angle less than 90 degrees and it's a reference angle. All right, this next one asks us to find the reference angle of, and I'm sorry, but I can't read that. So it looks like something over pi. Give me 2 seconds. I'm going to stop this recording. Actually, I'm going to stop here and I'll start the next recording on this problem because, like I said, I can't read it.